let's start with a simple problem based on Young's modulus. Okay, see, when you say problem, remember all the formulas. Okay, Young's modulus was what? It is y is equal to FL divided by A into delta L, correct? Now let's start with first problem. See, the problem goes like this. A structural steel rod has a radius of 10 millimeter and a length of 1 meter. A 100 kilonewton force stretches it along the length. Calculate, there are three parts: the stress, elongation, percentage strain on the rod. So it's given that the Young's modulus of elasticity of the rod is 2 into 10 to the power of 11 Newton per meter square. Correct? These are the given information. Now let's write down what is given. Okay, now whenever you start a problem, always write down what is given, then you write down the formula, then you start applying, and then you have to solve it. So this is more like a procedure what you have to follow. Okay, now I would give you guys a couple of seconds or couple of minutes. Please pause the video, solve the problem by your own, and then we are going to discuss how the problem goes. Let's start with the problem now. Now what is given? The first information, R is equal to 10 millimeter. Now guys, when you have 10 millimeter, remember you have to convert that, isn't it? So when you are converting it, so what you have, this will be 10 into 10 to the power of minus 3, correct? Or 10 to the power of minus 2 meter. Now this is the value of R, correct? Next, what is given? Length is given to be 1 meter. So you have L is equal to 1 meter. Correct. Next, what is given? See, they're telling 100 kilonewton of force. See, look at this, 100 kilonewtons of force. So write that one down also. So what you have? Force is equal to 100 kilo. Kilo is 10 to the power of 3. 10 to the power of 3. Which is 10 to the power of 5 Newton. Now, this is the force given. Now, what else is given to you? Very important one. The Young's modulus is given. See, this is the Young's modulus, isn't it? Now, let's write that one down. You have Y value to be equal to 2 into 10 to the power of 11 Newton per meter square. These are the given information. Now let's write down to calculate the stress what we have to do. Guys, what is the formula for stress? So first let's write down the formula. You have the stress which is given by stress is equal to force by area, isn't it? Now force is given, correct, and area you have to calculate. We can use pi r square. So force is 10 to the power of 5 divided by, now area is given, or area you have to calculate, to be honest. So pi r square is the area. R is given to be 10 to the power of minus 2, isn't it? So you have 10 to the power of 5 divided by, take pi as 22 by 7, which is much easier to solve. 22 by 7 into radius is 10 power minus 2. 10 power minus 2 whole square becomes 10 to the power of minus 4. 10 to the power of minus 4. Now, if you solve this one, then you are going to get the answer as 3.18 into 10 to the power of 8 Newton per meter square. Now, this is the stress what is being applied on the body. So, first part is done. So, what did we finish now? So, we just finished the stress part. Stress part is done. Now let's move on to the next part, which is the elongation. Now elongation is what? The delta L. In Young's modulus, what you have the delta L, right? That is the elongation. So for that, again, we are going to take delta L is equal to F by A, because F by A, the Young's modulus, you are going to transpose it. So F by A into L divided by Y. Okay, this is the formula. Now, F divided by A, you have already figured out F by A formula. Substitute, you have 3.18 into 10 to the power of 8 into length is how much? 1 meter. 1 divided by Young's modulus 2 into 10 to the power of 11. Okay, this is the formula, or this is the value. Now if you calculate this, you will get 1.59 into 10 to the power of minus 3, or you can say 1.59 millimeter. Okay, so this is going to be the elongation. So we are done with the elongation part also now. The next part what you have is percentage strain on the rod. Correct? This is the third part. For percentage strain, what you have to use? Strain is what? Delta L divided by L, correct? So calculate delta L by L, multiply that by 100. That's it. So for this one, you are going to have, so first is strain. Strain is equal to delta L divided by L. So percentage strain will be this into 100. Now delta L is how much? We just calculated that, isn't it? 1.59 into 10 to the power of minus 3 divided by, what is the value of the length? 1 meter into 100. So you are going to get the answer as 1.59 into 10 to the power of minus 1, or 0.159%. So this is the percentage strain on the rod. Now to understand or to write down the answers here, guys, remember we are looking at the answers for A, B and C problems, correct? So for stress, what did you get the answer as? 3.18 into 10 to the power of 8 Newton per meter square, correct? Then for the second one, that is the elongation, you got it as 1.59 into 10 to the power of minus 3 meter, correct? And for the third one, that is the percentage strain on the rod, it's right here, which is 0.159%. These are the answers for the three: part A, part B, part C. Okay, now understand the formula and see how you have to apply the formula and in each and every problem. Alright.